Hello! In today's video we're going to be going through LeetCode problem 543, which is diameter of binary tree. So this states, given the root of a binary tree, return the length of the diameter of the tree. The diameter of a binary tree is the length of the longest path between any two nodes in a tree. This path may or may not pass through the root. The length of a path between two nodes is represented by the number of edges between them. So in example 1, we have the binary tree 1, 2, 3, 4, 5. The output is 3, so it's either 4, 2, 1, 3, or 5, 2, 1, 3. And then the second example, we just have basically a 1 and a 2, so the output is just the 1 path. So to code this, the first thing we need to do is define an int, which will be our diameter, which will be the result. So we're given public int diameter of binary tree, inputting or passing in the tree node root. So we'll define the diameter to 0 initially, and then we're going to call longest path, and pass in the root. So this is where we're going to be using recursion. And then when that's all done, we'll return the diameter. So int longest path will pass in the current node. So if the node equals null, we're just going to return 0. Then we're going to find the left path, the longest path on the left. So we'll define a variable called left path and define it, or make it equal to longest path passing in the left node of the root node here. After that, we'll do the same thing with the right path. Longest path passing in the node right. And then we'll take that diameter will be the max of the current diameter or the left path plus the right path. And then we're going to return the max of either the left path or the right path plus 1. And that is the method. So let's debug this and see if we can't clear that up a little bit. And I have a handy dandy graph to go with it. So I took the first example here. Alright, so the first thing we're going to do is make a diameter of 0, and then we're going to call longest path with the root. So we're going to take the 1 here, and it's not null. So then we're going to call longest path again, but pass in the left node, so the 2 in this case. And that's not null. So now we're in the 2, and we're going to pass in the 2's left node, which is the 4. And it's not null. So now we're looking for a left path on the 4, which is null. And so that's going to kick that out. And now we're still in the 4, and we're looking for the right path. So we'll pass in node right, which will also be null. So this is the first time we've gone through both the left and the right. So the diameter is going to be equal to the max of the current diameter, which is 0, or left plus right. Well, the 4 node doesn't have a left or right path, so it's just going to return 0. And so it's going to take the max of left and right, which is 0, and add 1. So it's just going to return 1 for itself. Okay, so now we're back at the 2, and we just did the left path, which equated to 1 for the 4. So now we're going to go into the right path. And now we're in the 5. The 5 doesn't have a left, and it doesn't have a right. And so we're going to take the max of the left and right path of the 5, which is 0, and yeah, so take the left, right path and add 1 to it. So now we have left path and right path of 1. So now we're back at the root node. Or wait, yeah, we're at the root. No, I'm sorry, we're still at the 2 node. So now we have left and right path, which is 1 and 1. And we're going to take the max, either one is 1, and add 1 to it. So now we're back at the 1, and the 1 now has, you can see, has a left path of 2, so it has 1, 2. Now we're going to continue on the right path of the 1. And so we get to the 3. So now we're in the 3. The 3 does not have a left. The 3 does not have a right. So now we're going to do the left. We're going to get the diameter of the left and right path of the 3, or the current diameter, whichever is larger. And in this case, left, right, both 0 plus 1, so we're just going to return 1. So now we're back at the 1, and we have a left path of 2 and a right path of 1. So you can see that here, 1, 2, or 1, 2, and then the right path is just 1. So it's going to take the max of the diameter. The current diameter is 2. So we're going to add left plus right, and 2 plus 1 is 3. So now the diameter is 3. So the max of the left path, right path, plus 1. And that gives us the 3. And that is the answer. So let's run this through LeetCode. So let's run this through LeetCode and see what we get. Accepted. We'll submit. Faster than 100%. I love it. And use less than 98%. So this is pretty efficient. So let's go through the time and space complexity. Time complexity is O of n. So as you increase the binary tree, there's more nodes to go through. So it's O of n. And same with space. As we increase the binary tree, that's more space we need to go through traverse the entire tree. And that's it. So thanks again for watching. Let me know if you have questions, and we'll see you next time.